Okay, so boys and girls, I hope you're able to solve the question 3. So we continue this video. We are going to discuss the question 2b. The question 2b. So we read through the questions. An object of mass m is on a horizontal rotating platform. So this platform, we place it on a rotating horizontal platform. So the mass is located 0.25 meter from the axle. So the axle will be the center lah. And make one revolution every 0.75 seconds. So this thing is rotating, means that the mass will perform circular motion. It will perform a horizontal circular motion whereby the radius will be 0.25 meter, and then it will make one revolution every 0.74 second. So from this statement we can know how fast the mass or the rotating platform is rotate. So daripada statement ni kita boleh kira berapa angular velocity, berapa laju benda ni rotate, berapa laju benda ni rotate, berpusing. Okay, so kita boleh refer kepada nota kita. So angular velocity is angular displacement divided by time taken. So we know that we complete one revolution in within 0.74 second. We complete one revolution in within 0.74 seconds. So one revolution, we change it to radian, is well equivalent to 2 pi radian for one revolutions. And the time taken to complete one revolution is 0.74 second. So I'll get the angular velocity will be, so you might pause the video to do the calculations. So the angular velocity, how fast the object mass m rotates on the rotating platform, will be around 8.491 radian per second. Do you get the correct answer as mine? Okay, then the friction force need to keep the mass from sliding is 15 Newton. So we want to find what is the object mass. So we want to determine what is the value of m. So since the object is perform circular motion, so means that we have to identify what is the forces that point towards the center that supply or act as our centripetal force. Daripada situ kita boleh relatekan centripetal force tu dengan mass lah, sebab kita faham formula untuk centripetal force adalah mv² over r ataupun mr omega squared ataupun mv omega. Jadi kalau kita nak dapatkan mass, so kita perlu tahulah force apa yang bertindak sebagai centripetal force kita lah, yang membolehkan mass tu perform circular motion. So if I sketch the free body diagram for the mass m, so saya lukis di sini the free body diagram for mass m. So let's say this is mass m. So straight downward we have weight, and then we put it on the surface. So we put it on the surface. So perpendicular to the surface will be the normal force, and then we have a friction force to keep the mass from sliding. It means that we want to prevent this mass from sliding away from the platform, from the rotating platform. So kita ada satu friction force yang akan prevent mass ni bergerak terkeluar daripada platform yang tengah rotate ni. So mass tu cenderung terbuang keluar, so friction mesti bertindak ke dalam lah. Friction mesti bertindak ke dalam, ke arah axle ni, Okay, so we have static frictions towards the center of the platform, supaya benda ni akan rotate, dia tidak akan terbuang keluar, dia tidak akan terbabas keluar lah, So when you draw the FPD, you can see very obviously what force is pointing towards the center? Yes, the friction force is pointing towards the center of the circle. Okay, friction force is pointing towards the center of the circle. So we know that our static friction force will be our centripetal force. So centripetal force is mv squared over r, or we might use mr omega squared, or we might use mv omega. So which equation we want to use? So we check the information given. So since we know about the angular velocity, so I'll use the second one. So I'm going to equal to mr omega squared. So the friction force is 15. The mass we want to determine, the radius of the circle is 0.25. The angular velocity is 8.491 squared. Okay. So now you can determine the object mass. So again, you might pause the video to do the calculations. So if you calculate correctly, you might get the mass will be around how much? 0.83 kg. Am I right? You get the same answer? Okay. So I hope you get the same answer. So to enhance your understanding about the centripetal force, you can try questions 4 and also question 5 in tutorial 6. Okay. So boys and girls, in order to solve question 4 and 5, you may refer to the examples of problem solving example in your non-face-to-face SLT. You might refer to example 5, example 6, and also example 9. This example 9 will be quite similar to question 5 in your tutorial. Alright, in order to solve the question 4 and question 5. Then after you have tried question 4 and 5, you scan your solutions from question 1 until question 5 and then submit via Google Classroom before 14 September 2021 on Tuesday night. Okay, Tuesday night, 11:59 p.m. Then we will continue with the discussion on how to solve problem related to centripetal force on our next tutorial sessions on Wednesday, 11 o'clock.